Alright, welcome to the after work video. Last video I arranged my lab so that it would have topology that we're going to be going over in these documents here. So I had already prepared my notes and stuff for the next video. So let's look at that and work our way from top to bottom with the examples. Okay, so we're focusing on PIM-SSM, which stands for Source Specific Mode. I'm actually not sure what PIM stands for. I think it stands for Protocol Independent Media. No, it's just one of those terms where it's impossible to find the... Yeah, it's impossible to find it when it's not an acronym. Like they just refuse, like it's known as its acronym and nobody knows what the acronym actually means. Or it's actually PIM. Like it's not an acronym, it's the word PIM. But, yeah, I don't see anything. So I guess I'm not going to worry about it for now because we really got to go through and do this configuration ASAP. So yep, here's our documentation. I'm not sure what this source receiver means, and I'm not sure what kind of links we're going to need. Yeah, so this example works with the simple RPF topology shown in Figure 7. So I guess it's not even as difficult as this. It's super nice and easy. That's exactly what I'm looking for anyway. So, okay, so all we're going to need is let's see, what are we even going to need? We're going to need I can't think of what we're going to need for some reason. Okay, yeah, so just this point-to-point topology, I think, yeah, that's what I'm thinking of. So let's move this down here. Okay, and then here's going to be our topology. So router A is going to be like router 1. So let's quickly configure router A here. And then that should be all we're going to need. And then we'll be confirming our results. And we'll be doing the verification steps. And so yeah, let's do it. Okay. Okay, so here it is. PIM is a protocol. Yeah, I mean, I guess PIM, I'm not going to get an answer for that. I mean, oh, you know what it probably stands for? It probably stands for Protocol Independent Multicast. Yeah, that's exactly what it stands for. Protocol Independent Multicast. Okay. Looks like there's a really good Wikipedia on this. This seems pretty modern and relevant, unlike frame relay. Like multicast is like, it seems like it's really important nowadays with all the video conferencing and all that. So cool, I'm glad to be learning about it. So we're going to need to make a rendezvous point. So RP, router's rendezvous point properties. So let's do edit. RP. Take a look at what options we have. So we can register a policy, we can configure static PIM RPs, but we're going to go with local. We're going to set, I guess, this router as the RP. So edit local, and let's, oops, okay, so We've got address, set the local address. Oh, right, because if I go, I can't do edit local. Oh, I can do edit local. I'm not sure what happened there, but yeah, I can do edit local. So we've got address, local RP address, and we've got group ranges, group address range for which this router can be an RP. We're going to set both of those. Oops, then it's going to be 239, not 139. Okay, now we're going to need to add interfaces to it, kind of like how we add interfaces to other protocols, like we did for OSPF. Okay, and we'll add interface GE000.0 mode sparse. Okay, and let's take a closer look at the help menu. So we've got PIM interface options. Then we've got mode. We've also got like hello interval, local address family. So I wonder if, okay, I wondered if there was like something pertaining to having it inside of a VPN under family, but it looks like there is not. Okay, so we're going to need to set the mode, and let's see what kinds of modes we have. We have dense, we have sparse, and we have sparse dense. So SSM, yeah, so I don't think, oh, you know what, I think this is sparse mode. So yeah, I think we're going to be learning specifically more about sparse mode, and it looks like they're going to kind of not really worry about those other kinds of modes. Okay, then we need to add the loopback interface, as is common for a lot of routing protocols. Okay, now we need multicast routing options. So here we've got all the classic routing options where we can set the autonomous system, that sort of thing. So we have an option for multicast, global multicast options. So we can do a number of things here. We can create an SSM map. We can enable trace options. We can set the scope, but we're going to be creating a SSM group. Oh, but I'm in edit mode, so that's probably only available in set mode. Yep, so set SSM groups. Yep, so specific multicast group ranges. So we've got to set our ranges. Looks like we can set both of them at the same time. Like that, so that looks good to me. Well, okay, now that looks really good. So 239 and 232, and then they also want this ASM override SSM. So allow ASM state for SSM group ranges. So I'm not sure why they want that. We're going to be learning about SSM. That's the name of the, but maybe it's to enable backwards compatibility, something like that. So we're just going to go with it. We're going to add additional commands though. We're going to add trace options. Okay, let's see what sort of things we can trace. So we can trace the config internal, configuration internals, general, normal, configuration parsing, policy processing, routing information, state transitions. That one looks interesting, but I usually don't find it too overwhelming to have them all going. You know, it's all relevant to multicast anyway, so even if it's relevant to even if it's irrelevant, having some of that irrelevant information, I think, kind of gives you a better sense of what's working, how much work is happening, you know, that sort of thing. So it's not necessarily the worst thing in the world to enable all, because it's already filtered down to just being relevant to multicast anyways. Of course, it's better to be able to just see the things you're interested in, but I, at this point, don't know what I'm interested in. Okay, so we're going to do a monitor start multicast. Not monitor strat, monitor start. Okay, so we've got a monitor start multicast going. Next step is going to be to bring up the other side, I think. I'm actually not sure. So I guess the next step will be to do these verification commands. So the first one's going to be show IGMP group. Okay, so IGMP is not running. Yeah, I thought we were meant to enable. I'm confused here. I don't understand why. Yeah, I'm really confused here because I thought we were meant to enable IGMP. So this, unfortunately, might not be the best documentation. So of course, it's show. Okay, we've got a stats query do. Of course, if I do a show IGMP statistics, same thing, it's not running. Let's take a show PIM join. So now we're getting more information, but it looks like this is empty as well. So I think the reason it could be empty is just because that port is not up. So let's give it a port, and let's just put a IP on that port. So we do have a port added to PIM. We've also got a local address. So let's use this local address on the port, and then on the other side we'll make this a /24, and then configure the other side as well. I don't know if that's how the IP addressing is meant to be, but we have those trace route options running. So those trace options running, so we will see if it starts. We will see if that triggers anything. Okay, so we're going to be configuring. Yep. Okay, we'll make it a /24. Perfect. Okay, we'll make the other side a .1/24. Perfect, so that looks good to me. The next step is going to be to go back over to router 1 and see if any of those messages trigger. I'll make it wider so that they don't get all word wrapped and jumbled up. Okay, so unfortunately we don't have any messages. We did have some pop up here, but it seemed to be unrelated to the changes that we added. So let's do a show route and ping 10.255.72. I forget, it was kind of like a random address. 46. Okay, so yep, everything is good to go as far as pinging that is concerned. So I'm not sure more about what they're getting at here. It's really unclear, this example. I'm kind of tempted to just move on to the next one. I'm kind of tempted to read this. Let's read that before moving on to the next one, because okay, so here's SSM only, and this one is any source override. Okay, so to deploy SSM, configure PIM sparse mode on all routing device interfaces and issue the necessary SSM commands, including specifying IGMP v3 or MLD v2 on the receiver's LAN. If PIM sparse mode is not explicitly configured on both the source and group members interfaces, multicast packets are not forwarded. Source lists supported in IGMP v3 and MLD v2 are used in PIM-SSM. Only sources that are specified send traffic to the SSM group. In a PIM-SSM configured network, a host subscribes to an SSM channel by means of IGMP v3 or MLD v2. To join Group G and Source S, see Figure 4, the directly connected PIM sparse mode router, the receiver's designated router DR, sends an SG join message to its reverse path forwarding RPF neighbor for the source. Notice in Figure 4 that the RP is not contacted in this process by the receiver, as would be the case in normal PIM sparse mode operations. The SG join message initiates the source tree and then builds it out hop by hop until it reaches the source. In Figure 5, the source tree is built across the network to router 3, the last hop router connected to the source. Using the source tree, multicast traffic is delivered to the subscribing host. SSM can operate in include mode or in exclude mode. In exclude mode, the receiver specifies a list of sources that it does not want to receive the multicast group traffic from. The routing device forwards traffic to the receiver from any source except the sources specified in the exclusion list. The receiver accepts traffic from any sources except the sources specified in the exclusion list. This example works with the simple RPF topology shown in router 7. So it looks like I also need to enable PIM sparse mode on the interface, and then I think they gave me the necessary SSM commands, but let's see if we can enable PIM sparse mode on the interface and just Google it out and figure it out. So I mean, the thing is, this looks like this is the command that configures PIM sparse mode, but maybe we need some sort of family, something like that. Let's take a look. So maybe there's like an encapsulation for multicast. Nope, don't see anything like that. I wouldn't think there would be. Anything for multicast, multi-chassis protection, Giga options, anything under there? Nope. What are the MPLS pop-all labels? Let's see here. So, yeah. So let's go into the units. And maybe there's a special kind of family? No. So I think it is. It's how it's meant to be. What they gave. They weren't leaving out configuration as they do sometimes for other kinds of examples. This is everything we're meant to have. It just for some reason it doesn't seem to be working. Maybe I needed to enable IGMP. Yeah. All right, let's see if this works. Yeah, I didn't have IGMP turned on, so let's see what happens if I turn that on. Hopefully I get flooded with messages. Come on, message me. Nothing yet. We could probably do those IGMP commands though, but the problem is they didn't give us any output to compare it against, so I couldn't even tell if it were going right or wrong anyway. But let's do them and see what pops up. Okay, perfect. So yeah, this looks a lot better now. It looks more related to the configuration we added in because we did create some groups here, SSM groups. But it looks like these are just generic default groups not related to our configuration. You can tell that from the first octet there, which is just used the generic octet for multicast traffic. All right, so let's do the next command. Okay, yep, that looks a lot better here. And then final command. Okay, but we still don't have anything joining up in the PIM, so unfortunately that was kind of a bust. Let's move on to the next one. Hopefully this one will be better. Okay, so this is configuring PIM-SSM on a network. The following example shows how PIM-SSM is configured between a receiver and a source in the network illustrated in Figure 8. This example shows how to configure the IGMP version to IGMP v3 on all receiving host interfaces. Okay, so yeah, let's go with that. So we're just gonna wipe everything and start new. All right, and now let's get a topology that looks more like what they have. Right now I've got this point-to-point topology going, so we'll even go ahead and get rid of the link. Okay, that looks good to me. Alright, that looks good to me. So it looks like the wiring is pretty clear. So let's do well. Okay, so I'll just start with 0 to 0, and then 1 to 1. Okay, and then 0 to 0, and 1 to 1. Okay, so now the next step is going to be to enable IGMP v3 on all host-facing interfaces. So they don't, unfortunately, label which interface is host-facing and which is not host-facing. I'm going to guess that these receiver and source are our hosts. So let's kind of expand out the topology a bit. So we're going to use this as the source host, and we'll use this as the receiver host, assuming that these are actually hosts. I don't see any sort of indicator that would prove that those are hosts, but it seems very likely to me. Okay, so let's wire those up. We'll wire it G9 to 9, just so it's clear that it's an endpoint and not a part of the actual network. Okay, so on all host-facing interfaces, disable IGMP on the core and enable IGMP3. So as far as I know, that's just going to be these two interfaces on R1 and R3. Oops, so yeah, before we do anything, okay, and they want it to happen on the host-facing interfaces, which is really confusing to me, why they would use this interface all, because clearly not all of the interfaces are going to be host-facing on any of these routers. In fact, for two of these routers, assuming these are hosts, there won't be any host-facing interfaces. So this is really unclear. And it looks like they're talking about router 1, so I would think that on router 1 you would only have this being the host-facing interface, so to enable them on all already does not properly follow the instructions given there. So we're going to go one level above and just enable it on the necessary interface. So let's do set protocols, IGMP, interface GE 0000009.0 version 3. Perfect. Okay, and I guess I want to give it an IP. I'm not sure if it needs one. So when you configure IGMP v3 on a router, hosts on interfaces configured with IGMP v2 cannot join the source tree. Okay, so yeah, let's commit that, and then hopefully they'll give us... Oh, okay, so they're making things a bit more clear. I'm confused. I'm really confused here. So let's do the command, IGMP interface. Okay, so we don't have any IGMP interfaces. So here's the courier IP, so this isn't going to necessarily be the IP configured on this interface. Okay, so that was confusing as heck. Not super productive. I'd rather not just do another one that's not productive and that's not going to kind of have it all come into place and have actual verification steps that I can verify. So I think this one is more complete. So I guess I'd rather just do this one, which has 1, 2, 3, 4, 5, 6, 7 routers, because I think we're going to get some good verification steps, all that sort of thing. Like, this looks like one of the better. Okay, so yeah, let's go with the verification steps, or sorry, with this example, because it looks good. And then once I'm finished with that example, oh man, but I'd like to do these policy options, because this might. Oh my god. I wish these were more clear. Ah, man. I hate to just skip this over because this is going to come up on the test, I bet. Alright, but let's see if I can get through this. Okay, so let's set up the topology, and I'll roll back or I'll do a blank out. Okay, I've got a blank out. Okay, so we've got two hosts. Move this down. Yep, down like that. And then we've got two hosts up like this. Perfect. Okay, and then sever this link. I don't know what P1 means. And I don't know why a CE router would go to a P router. I would think only a PE router would go to a... Oh, because this is the... Okay, this has a special multicast connection. Okay, that makes sense. Let's just get rid of all of the cables and rearrange everything. Yeah, I've got the air conditioning, I've got my thermostat set to turn on air conditioning if it gets too hot because I'm in Texas, but today is a particularly cold day and I don't have it set to turn on if it gets too cold. So last time I checked it was like 61 in here, and it's like, well, I don't feel like super like bad, but I feel bad, so like I probably should turn it on. Yeah, I'm probably gonna go turn it on. Let me arrange these and then I'll go and turn on the heat. Otherwise, I'm just not going to be able to focus properly if I'm too cold. Okay, so we've got, we'll use R1 as CE1, R2 as C2, then, yep. Yep. Okay, we just need, oh no, we're gonna need more because we're having hosts. Okay, we will have an extra unused router. Perfect. Okay, so here's our topology. So they're doing one-to-one here. Okay, so let's cable it up. 0 to 0. 0 to 0. 1 to 1. 1 to 1. 0 to 0. Okay, and then 0 to 2, 1 to 2. All right, so that looks good to me. So yeah, I got to turn the heater on. I'm just not able to focus the way I need to, being this cold. So, unfortunately, God damn it. I thought this would be like a really good one. I mean, if it's just enabling L3 VPN, that's what I did last time, so I know how to do that. Yeah, it's just a VRF. I did this last time, so I know I've got my PE routers, I've got my CE routers, and then it looks like there's special hosts. So I should be able to figure this out. Why don't I do one thing before I turn the heat on? Well, let me put it this way. Why don't I just go turn the damn heat on? What's wrong with me? But let me do one more thing. We're going to change this to be host 1. And then this is going to be host 2. Okay, and then CE1 and CE2. Okay, and then PE1 and PE2. All right, and then P1. Okay, I'm going to turn the heat on. I'll be right back. Okay, I'm back. It's starting to warm up a lot in here. Feeling a lot better, so yeah, so let's get started on. So this is interesting. It says P1 to P1. I think basically this is meant to be PE1 to P1. I guess I'm not sure what they mean by that. So it's SO. Yeah, so it's meant to be PE1 to P1. And this looks like configuration on PE1. So this is just a typo bonanza. Most of these are, but hey, it's better than nothing. And it's all freely available too. So, okay, so we're going to start with PE1 right here. All right, so let's configure this. You know what? I think I'm gonna add descriptions before I do anything else to the ints. It's just gonna make it easier on me. So let's add yeah, so I'll add my own brand of descriptions. We'll add it to all of the devices. Okay, looks good to me. Alright, so let's set system host name, host 1, perfect. So next step is going to be to add a description. Let's figure out which interface is up. Okay. And this is going to be to CE1, I believe. I'll check. Yep, CE1. To CE1. Okay, moving on. Oops. Oh, so this already has a IP on it somehow. Okay, so it's left over from the last one. We'll clear this off. Okay, and then add this back, and then set interfaces. And I believe it was 0, yep. 0 description to C2. So let's take a look at the candidate configuration. Looks good to me. Let's take a look at the changes. Okay, looks good to me. Yeah, we had a lot of pre-existing configuration in the active config. So everything looks good now. Let's move on to CE1. Okay, let's get our labels up. So CE1 set okay, that looks good to me. Yep, looks good to me as well. Okay, on to the PEs. So, okay, so that one is going back. Okay, I'm gonna send a text. I should probably pause while I'm doing this, but I am. This will depend how long this video goes, so I'm just gonna do this quick. Okay, moving on to PE2, right? Yeah. Oh, I did a show instead of a set. I do that sometimes. It's not too distracting, but this is why I want to get as much experience on the actual CLI as possible. So little things like that don't trip me up on test day. Okay, so now we can follow, oh, well actually we got one more. False finish line, world's most demoralizing thing, from what I understand. I guess like I watched this like military thing on like Navy SEAL training or something like that, and they said like false finish lines are like the most demoralizing, soul-destroying, crushing things, and kind of the whole point of this training is to have people be resilient in the face of challenges. So it's like they give them a false finish line for just about everything. They say, like, okay, go run 4 miles. So they go run 4 miles. And they say, well, run an extra 2 miles, run an extra 2, run an extra 1 mile, run an extra mile. Okay, run 4 miles again. Like it just never ends. Like whatever. In this training I was watching the video about, whenever they say it's done, it's not done. So that's kind of how I feel like here. But it's definitely gonna be. I mean, if I fail, I might want to take it again, but I don't know if it's going to be worth the expense. Like, it's an expensive exam. And like, hopefully these like video lessons and stuff would be enough. Like, maybe if I end up failing and someone wants me to try to retake it or something, I could do that, but I'm planning to kind of move on from it if I fail. Okay, so 000 is going to the left. All right, so finally we're good to go. So let's do it for real this time. We're gonna go on PE1. We're not gonna do any of the descriptions, anything like that, because we've got our own. Okay, but we will be following their IP addressing scheme. Hopefully it makes sense. It looks like they're using ISIS for their IGP. Looks good to me. So now here's where those descriptions are really valuable, because this is the one to P1, so we know it's going to be G002. Okay, so we got one more left. Okay, so this is interesting. They actually have a IGMP configuration now. They didn't have that in the last example. But it makes sense. I mean, if it's a protocol, it's got to be enabled under protocols. So if it ends in a P, it's more than likely a protocol. I guess MPLS is the only exception to that. I wonder if they're all end in P. Let's see. No, there's some that don't end in P as well. BFD. Okay. Ah. Okay, we'll just follow along. This is the management interface. Yeah, so let's move on to RSVP, and this is our baseline MPLS configuration required for our layer 3 VPN to ride on top of. So we're going to need the two core-facing interfaces. So 0 and 2. All right, and then of course we're going to need our full mesh of LSPs. Oops, it looks like they're adding an LSP to the PE. I don't think that's going to be necessary, unless, yeah, I don't think that's necessary. So that's pretty surprising. Let's try it anyways. I'm just hesitant to go off the rails at this point. Okay, I'm not sure what this primary PE1, PE2 prime means. Are we going to be making another one called that? We are. So we're going to be making a path here. Yeah, and that's going to be the... okay, so this is how we specify that we want it to be a multicast LSP. We create a path with the multicast address. I believe this is the address of the rendezvous point. I'm actually not sure. But let's do edit, label, switched, path, PE1 to P1, 18, primary, prime, perfect, okay. So yeah, now here's those policies we called. We did not define them yet, so let's do that right now. It's going to be under protocols MPLS, path, but I do need to give it the address of next system in the path, which is going to be the multicast address. Oops, I think I need some water here. Okay, so before I move on to BGP, I'll get a glass of water, so I'll be right back. Okay, so I'm feeling much better now. Let's configure BGP. So here's our, this is just for regular traffic. Here's for our VPN traffic. We're going to need to enable this as well. And then here's the special traffic, the special for multicast traffic. So we can choose between unicast, flow, or multicast. We're going to choose multicast because that's the topic we're learning. So looks like we need one more address family, inet-MDT. So IPv4 multicast distribution tree. So we need to turn that on. Signaling, include IPv4 multicast, VPN, auto discovery, and LRI. Okay. Okay, time for protocols OSPF. Okay, so just like our other protocols, this is going to be the core-facing links. Okay, so next is going to be configuring PIM, which is Protocol Independent Multicast. Okay, so we've got a number of things we can do here. We're going to set the assert timeout. Now this is the kind of stuff that might be really helpful for me on exam day to just go ahead and set up, because if it saves me time, you know, a minute, 5 minutes, 10 minutes just sitting and wondering if something's going to be good or not, that's going to be really important. But of course there always is the danger that you get fancy, you didn't keep it simple, and now you're spending an hour troubleshooting, you know, just some basic command you entered. Creating problems for yourself is never a good idea, even in the name of preventing problems. Okay, so here's the customer-facing interface. Oh, I guess you can always keep the route distinguishers simple. I haven't been doing that, but I might do that on test day and going forward. Although it does help because that's what shows up in the table. So if you don't keep it simple and you actually use the loopback or something like that that identifies it to the specific router it came from, you can see at a glance where it came from in the table, which can be nice. Perfect. Okay, so yep, there it is for PE1. They're giving us the step-by-step, all that sort of thing. So what I'm looking for is configuration for other routers. I don't see any given, so we might have to just go our own way, but luckily I should be able to just figure that out based on the work I've done on in the past. So yeah, this will actually be a fun exercise because I know how to set up a L3 VPN. I'm really confident with that right now. And then we have the configuration here we can use as a template for the other side. So let's jump over to PE2 and get that to go, assuming this commits. If it doesn't commit, we'll need to troubleshoot. Okay, yep, so we got to troubleshoot. First things first, it looks like this prime is not defined, so let's just look at everything that matches for the word prime. So it looks like I forgot or I added an extra E here. Oops, oh wait, no. One of these is not named correctly. Let's see which one it is. So we're definitely going to have a PE1. But we're also going to have one here. This is going to be, so this one's not named correctly. Okay, so let's name it correctly. It's going to match the name, or I'll just type it out again. There we go. Okay, so hopefully it will commit now. Oops, we got another problem here. Oh, okay, so something that's interesting I noticed that I actually just decided not to follow is that they have two different loopback addresses, loopback unit 0 and loopback unit 1. They added unit 0 to OSPF, but I didn't understand why they did that because there's no interface on it. So, there's no IP address on that, so I really don't understand why they're doing that. I think it just doesn't need to be added to OSPF. I mean, I can follow exactly what they have, but I think instead I'm going to delete it from OSPF in the default routing instance because it's just not necessary. It doesn't have a IP address on it, and then add it to the routing instance. Okay, I don't need to add it, it's already there. It was in two different routing instances, that's why I was getting an error during the commit. But that is fixed, I removed it from the default routing instance. Oops, so LO00 not configured under instance PIM.master. So let's do a configuration, pipe display set, pipe match, PIM. Oh, maybe because I can't, you know what, I should probably just follow, what they had, because getting fancy like this is not working. Oh, actually this seems to be working when it takes this long. Yep, there we go. So I think it was the same deal. We've got protocols PIM under a custom routing instance and then under the default routing instance, so you can add it to both the default and the custom. And I don't see the point of adding it to the default if there's no IP address defined on it. There's simply a description. Not only that, there's no command like there was before, peer unit, where you can tie it in from a L3 VPN instance. So I'm not sure what they're getting at that with this. Maybe they forgot the peer unit command. Maybe they're just trying to make a point. But there's been enough errors in this documentation that I kind of trust myself on this one. I think by this point, too, taking the test the time is ticking, like 3 weeks or something. Like, I'm probably one of the foremost experts on Juniper service provider at this point. Like, even the person who wrote the doc, if they're just a deck writer or anything like that. Basically what I'm trying to say is making a judgment call, I think, is appropriate for me to do at this point. Okay, so we got a whole bunch of stuff here. Let's filter it out and make sure we've got the right. Okay, so we've got some /30s. That makes things nice and easy. Just means, yep. So that's good news. Now we might have to pick out our own links because we're not given any configuration except for PE1. So we just got to come up with what the rest of it will be on the fly. But that's okay. I think. I hope that's okay. Yeah. Yep. So this is going to be to PE1. This is going to be to CE2, and then this is to, yep, so that looks good to me. Okay. Now I'm just completely lost because I don't understand. And especially since it's multicast, like, do I use the same IPs then? I mean, that makes sense to me. If it's multicast, you would have one IP to many of the same IPs. Yeah, I wish I had a better lab for this, or a better documentation for this. It's really strange because it seems like a really complicated topic. It almost seems so complicated that there's really no way to even explain it in a way that is clear. Kind of like quantum physics. There's like a quote that if you think you understand quantum physics, you don't understand quantum physics. And like only 2 people in the world actually, in the history of humanity, actually fully understand it. Oh, I'm getting a delivery pizza from Domino's on Friday. First time in like 5-10 years, but I was really surprised to learn that Domino's actually has a vegan pizza, so I wanted to try it. I didn't think like any mainstream like fast food place would have good vegan options. Like I've heard that like Taco Bell does, but like it's literally just like beans in a tortilla, or like really bad. But like Domino's, you can get like they have like 2 different sauces that are vegan. Like they have like a barbecue sauce, and then it's kind of like Subway where you can pick out your vegetables, so you can just load it up with, you know, a stack of vegetables. So yeah, it sounds like it'll be good. Okay, so let's see here. Oh man, I'm just, oh, you know what I'm doing? I'm doctoring up this config and applying it to PE2. I think I can do that. It's not going to be as easy as I think it will be, but we will definitely try it. So, okay, so here's a freebie. Got to be .2 because it's across the link from PE1. Now, this one's not quite a freebie. This one's a little bit more challenging. Let's go with, so we've got 3 here. So let's go with 3.1 here. So anything, actually let's go with 3.2 here because it'll be for PE2. Okay, so we'll use a similar convention here for the connection to the P router. We'll just throw a 2 in the 3rd octet. Hopefully we can do that for all the IP blocks, and then that will give us our unique address. Okay, so here I don't understand. Let's try making it unique. So let's throw a 2 in it, right? No, surely not. Surely not. Absolutely not. Now let's skip this and come back. We'll add 3 question marks, and then when I'm done with everything, I'll search for the question marks and resolve it. Okay, but everything is going to be the same here. Oh, we got to do some, so these are all going to source from router 2 now. And then these are going to go to router 1. Okay, so with any luck, router 1 is going to be configured with IP here. So we've got a loop back for P1. P1 loop back. There we go. Okay. Huh. I'm kind of confused here. Oh, right. Okay. So we've got to verify. Oh. Wait a minute. Okay, now I'm really confused. Now I'm really confused. That makes no sense. So this should be a IP address on PE2. So unfortunately we won't have this IP address. We won't know what this is on PE1. I'm thinking maybe it's this here, the local, yeah, because this is going to be the, now what's strange is this isn't the loopback address. What address is this? So it's the RP local address. That makes sense. So yep, I think in our case, we're gonna form it to .16, and then our RP local address is going to be .17. Okay, but it should be the same for PE1. Oh, and then we're going to need to switch this. Okay, and let's see where this is configured. Now, this shouldn't be configured on this router because this is a IP meant for the other side, but we should have perhaps a .1. No? We should have something. Okay, we do have a clue here. Aha, so it looks like, yeah, so we would, so let's open up PE1. Okay, we already had it open. So let's do a exit, show configuration, pipe play set, pipe match 1.0. So we've got, I'm confused. I'm really confused here. Oh, no, I'm not confused. I'm not confused at all. So we've got protocols, and we're forming a connection just directly across the wire to the physical interface. So across to GE2. So show int descriptions. In this case, it's to the P, but we're also doing one to the PE. Okay, so that makes it nice and easy. It's just going to be .1 on the other side. Oops, except for no, it's going to be completely different because it's going to be the, so it's going to be .12 .2. Yeah, and then, but this, yeah, okay, yeah, this makes sense. Okay. And then I think because one thing I'm confused about, yeah, so the P router is going to get a RP local address. I thought there was only one rendezvous point though. I didn't think you put a rendezvous point on all of the, like that's what a rendezvous point is. Like rendezvous, I thought meant like meet all in one area. Ah, this looks like a really good one. Yeah, this is just going to crush me on the exam if I get it. I might be able to figure it out. Like, there's a lot of good documentation, I think, built in. But I don't know what that's going to look like. They might even have special routers without help apropos for the exam. I don't even know what the testing engine's going to be like. Like, are they just using a remote server the way I'm using it? Or like, yeah, I'm scared. Okay, so, okay, let's keep working on the config. So, yep, this is all freebies here. Yep. To .17, yep, so freebies, yep, all freebies. So this unfortunately is not a freebie. We gotta know what the loopback address is. Oh, you know what, this one's kind of a freebie though. Oh yeah, and we got the answer to this now, because we can see they're creating a full mesh of OSPF sham links here. So we know our local is going to be .1, and then we know we'll need to connect to .0 and .2. Okay, that looks good to me. Yep, freebies. Yeah, it looks free to me. Looks good. Yeah, everything else is a freebie, so we're good to go. The only thing is this is gonna be a routing instance to CE2, so let's name it that. Perfect. The names don't have to match across the router. The only thing that has to match across the routers is the route targets. And of course the instance type and the families. Okay, so we're good to go. Let's paste it in. Oops, I forgot to, we don't even need that. So let's get rid of that. And let's start pasting. Oh, it looks like this video's on 1.5 hours. That's a sustainable pace. It's a bit ambitious, but it's not too bad. I think I can take it. As I said, you know, burnout is a thing, but we've only got really less. We've only got about 3 weeks, so we're now measuring it in weeks instead of months. And it's an exponential. It's not like once you start measuring it in, you know, it's an order of magnitude closer now than it was before. And since it's now weeks and no longer months, it's actually getting shorter. It's exponentially. The test is exponentially closer than it was, and we'll soon be measuring in days. So. Right now, it's definitely more than fair to measure in weeks. We've got about 3 weeks, but very soon it will be measured in days, how soon the test is. So there's really no reason for me to concern myself with burnout now when I'm going to be done soon. Yeah, so in about 2 weeks, 3 weeks, definitely going to be measuring it in days. And I've only got like 3 weekends left, maybe even 2. I'm kind of concerned about that. Let's take the moment and see that. So I've got this weekend, then I've got the weekend of the 7th, then I've got the weekend of the 14th. So I've got 3 weekends, and that's it. And then I am taking the test, pass or fail. It's not up to me on test day whether I pass or fail. It's up to me right now whether I pass or fail. If I don't study, I won't pass. And if my study techniques are crap, I won't pass either. I'm hoping this will work, but I'm a little bit worried that I haven't been doing Anki, but I should be able to. If I'm really worried about it this weekend, I can do something about that. In fact, I probably will at some point once I finish up my topics and stuff. Because I am really worried about that. That's been an essential life-saving tool for me for the last up until now. Oops, so it looks like I've got another problem here. I forgot to change the name of these here. Okay, so we can delete that. Oh, that's strange. Okay, it was able to commit it even though there was an error. I've never seen that before. Perfect, we're good to go. So we're gonna have another step coming up. That's the P router. Here it gets a bit more interesting. I guess I'm not exactly sure what's going to be required for this one. But yeah, let's just work on it and then do the verification steps afterward. Okay, so show int descriptions. Okay, so this is to P1. So we need this subnet. Yeah. So this set interface. Yeah. Perfect. Yep, that's it. Okay, so edit int. Oh. Okay, I'm just going to make extra super sure. Okay, so yeah. Okay, I just wanted to make sure I had these right, because this is where it gets contentious. Also need loopback. And that was evident by the other configuration. Okay, so I've got all my IP addressing done, at least when interfaces are concerned. I don't have the IP addressing for Multicast configured yet. Okay, but we are going to need these protocols configured. So one thing I am noticing is not only do we not have... So I'm just questioning why they have family ISO. I thought it was because they were using ISIS, but they are clearly using OSPF. So I'm wondering if it's required for Multicast. This is really confusing. More than likely, it's just them not having the technical writer who made this kind of like. I guess what I'm trying to say is this documentation has is definitely not bug-free, that's for sure. Okay, so we're moving on to G1. Yep. Okay, so yeah, this looks good. Next step will be the INET address, which from here, yep, so we're going to use .2. There we go. Yep, everything looks good. Oh, we got different interfaces now. Okay, so we might need, yeah, because I think we might need unidirectional or bidirectional LSPs, so let's set that up. Okay, so we're going to do like this and like that. Okay, so then the next step is going to be this, right? Is that right? Or is it going to be something else? No, it's going to be something else. So it's going to be so we don't Okay. Let me just get the naming right. It's going to be P1 to PE1. We're going to have that one. And then we're also going to have P1 to PE2. Okay, so we need 2 statements for this. All right, and then we need 2 statements for that. Okay, so yep, and then we've already got these because we know this is to PE1, so the source doesn't really matter. We just need the destination. Oh, but we don't have it for, so we'll need to check on here. Okay, so here it is. All right, so now it's going to be P1, PE1 prime, P1, PE2 prime, oh. Okay, so we're going to need to use the naming here, and then this is going to be for. Ooh. Okay, I didn't copy for some reason. Okay, so to P2, it's going to be this. That's a freebie, but we'll need to go and get the one to P1 by logging on to PE2. Okay, so the P1 is going to be this. Perfect. That wasn't too difficult. Okay, these are all freebies. Oh, except for the local address, which is going to be 18. All right, so now it's going to be 16 and 17. Hopefully I got that right on the other ones. I might have gotten this one wrong. Dot 1, 18. Oh, right, and this is a PE, so we won't need wait a minute. Well, we definitely won't need any. Wait a minute. I'm confused. Because why do they have sham links to, so do I need a sham link in the default instance? You know what, maybe that's what I need. Okay, let's add a sham link to the default instance. So it's going to be sham link local. And then it's .2. But it's here. Okay. Yep, and then Shamlink remote will be dot Yep, dot 0 and dot 1. Yeah, it doesn't have to be in the routing instance, I believe. Oh, I think we're going to need to add the loopback address. Okay, looks good to me. Okay, so maybe this provider tunnel command is just going to have a default instance. Okay, and then we can add this to the default instance, maybe. Maybe it's just not necessary. Yeah, I'm so confused. I have no idea. Okay, let's just try adding it to the default instance. And this as well. Okay, and we'll just add the loopback. Okay, let's try this. I'm not too confident, but it's better than just doing nothing. I'm pretty confident in my PE configs, except for the IBGP config full mesh. I might have that wrong. Oops, so syntax error. Oh, I see. I need the word primary here. There you go. There we go. Okay, so we've got another problem here. So let's do sham link. So pipe match sham. Oh, I see. I don't need. Oh, I need a dash. Okay, I guess I'm not sure how to specify the local. Maybe if I just specify like the router ID. Yeah, so like set routing options, router ID. Maybe that'll work. Oh, so here we've got problems. Yeah, so I guess I'll just leave that out. Yeah, this as well. All right, so let's try this. All right, hopefully this works. I have no idea if it will. I don't think it will. Oh, okay, so local sham endpoint must be configured. I'm not sure how to do that. I mean, that's what I tried to do. It wouldn't let me do it. Okay, here we go. Looks good to me. Okay. Time for the verification steps. Okay, so unfortunately they aren't very forthcoming. But, I mean, we should see... Oh, actually I'm not sure what that was for. This is the one we're doing. Okay, so it's... Okay, here we go. So... I'm going to start show route table, or just show route. Okay, let's try show PIM MVPN. Nothing. Show PIM MDT. Brief. Oh, we gotta have a... Okay, not getting anything. Let's try it on PE1. Show PIM. Show multicast. Interface. Route. Show route. Oh, we do have a functioning MVPN, it looks like. Oh, that's interesting. INET 6. Okay, so this stuff appears to be functional. Okay, so we're not getting any multicast sessions, anything like that. So yeah, I think I'm gonna be happy with this. Kind of not a lot of action on this. A lot of what I did was kind of read stuff that I immediately forgot, set up the lab, and then I tried to go through some examples, but the documentation just wasn't good enough for me. I just, I typed in a lot of stuff, I committed it, but I didn't do it knowing why or how it would work or anything like that. I was hoping the documentation would be able to spell that out for me, but it looks like most of this... Oh. Okay, so it is telling you to do this on particular routers. Let's see if I got that full mesh going, because I think I might have messed up on that. On my IGMP configuration. Yeah, that's what I thought. I messed up on my IGMP configuration. So we got 16, 17, 17, 18. And we've got, see, we've got 17, 18 on here. So this needs to be to 16. Perfect. Oh, sorry, I'm kind of wandering off here. It's been a long day. So let's see here. Let's go ahead and oh, okay. Well, I can't. Well, yeah, my brain's shot. I need to give it up. I'm at the almost at the 2-hour mark too. So let's try this. Let's do a show BGP summary. Okay, and let's try to get these BGP neighbors to come up. Okay, so we want to go to .14.216, and ours is, yeah, we don't have this configured anywhere, right? Oh no, we do. We have it as the PIM-RP local address. I'm kind of feeling bad right now because I was supposed to have a blank interface with just a description on it. I mean, I can add that now. I just have it be. You know what? I'm going to try that. I'm going to add because I just took some liberty here, and I saw, oh, this is blank. What the heck? I'm not going to use that. And I put this address on the unit 0. So what I can do is just create a unit 1, and have that be the blank one. Okay, and now where it calls out adding unit 0 to the config, I can add unit 1, and then when it called out adding unit 1, I've already got unit 0 in there. Yeah, so here I can add unit 1. Okay. You know what? This is it. This is it. I bet it depends on a blank interface. God damn it! Shame on me for trying to get creative. Okay, so now we've got LO0 added to the routing instance where they have LO0.1, but I think that's going to be fine. Yeah, we've just got a blank LO.1, no family, no nothing, but we're adding that to protocols PIM, so Let's see if it works. Alright, so no problems with committing, so let's try that on the other ones. Okay. All right. So, yeah, looks good to me. I don't see anything wrong. Okay, let's try the same thing here. Oops, so I don't think we're going to need the same thing here, because we've got we do actually have an IP address here. Oh, we have PIM statistics now. I don't think we had that before. Okay, so let's try the verification again. Yeah, so that's my bad. I actually needed to have that. I just kind of assume that the doc has things wrong, but often it does not. Okay, I don't see the MDT anywhere though. Oh no, there it is. Show route ce1.mdt.0. Oh, table. Yeah, there we go. Okay. Now we can do show PIM MVPN. Aha. Yep, so that was the problem. Okay, well, good to know. So show PIM MDT. Oops, we need to provide it with a range. 232.1.1, is that right? Detail? Oh, we have to specify the instance. Okay. Cool. I didn't think that would work. Okay, we should have one incoming entry. I don't see any entries incoming. Yeah, we don't have any incoming entries, so there's still something very wrong going on. Oh, you know what? Maybe there's not. The thing just might be that my CEs aren't set up. So how would I set up my CEs? Okay, so obviously I would have a link there, and then I would have an extra port. All right, let's set up the CEs. Okay, so the CDs are going to use BGP or yeah, OSPF. Yep. Okay, so this is going to be dot 2. Oh my god. Whew. Okay, this is actually turning out to be more useful than I thought. Alright, I'm going to get to dot 2. Alright, and then let's just go ahead and simulate the rest of the IPs with loopback addresses. Okay, and then the last step is going to be to enable protocols OSPF. Okay, so that looks good to me. Let's see if we can make it easy on ourselves on the other side. Oops, so multiple loopback instances not permitted in master routing instance. So we can just put more than one IP on unit 0. Oh, well, I deleted it, okay. Okay, this should work, hopefully. Perfect, it works. So let's grab this. Alright, and then doctor this up so it's easier on the other side. Won't need to override the descriptions. Okay, so this is going to be take a look at what it's going to be. So this is C2, it's connecting to P2, we won't need these anymore. This is why these descriptions are just so essential. This is because thinking is the bottleneck. The more you've got to think, the less you've got to do. So the descriptions, I don't even have to think at all about what it's hooked up to. It's important to think, in my opinion, but it's just thinking too much is not a good idea. It's not an effective strategy. Okay, so yeah, that looks good to me. And then we won't need this special one here. We're just going to need this, and then of course we'll need that as well. That looks good. Okay, and then this is going to be 224. Well, bam, perfect. Everything is perfect. So this goes on C2. Okay. Okay, so now that we've got our CE set up, let's go back to the verification step and see if things look different. So we should see an incoming entry on PE2. Oh, and you have to specify a instance. Oops, and we'll probably only see it on CE2. You know what? Maybe we're only going to see it on the. Let me go back here. Yeah, maybe we're only going to see it on this device here because they're connecting to each other like that. So let's check that device. Oh, we're well past the 2-hour mark now. Oh God. That is not what I want to hear. Oh, right, and the goal is to check incoming. Nothing. Okay, yeah. So I thought we were gonna have something incoming, but apparently we don't. So yeah, I'm confused. I don't understand it. It's complicated. Yeah, we don't have. Oh, I'm surprised we don't even have. Oh, you know what? Maybe I've gotta like configure PIM, but didn't I have trouble with that? Like, if it's MDT, I'm confused. Do I need a routing instance on the P router? I've never heard of that before. Are my BGP neighbors up at least? I'd hate to just leave it without having that up at the very least. No, it's still idle. These aren't even valid because without PIM up, it's not gonna. Yeah, there's not even a route to those hosts because I don't have PIM working. God damn it. Do I have a tunnel like that configured? I do. What address is meant to go there? Routing instances. Group address. Okay. Do I have a sham link? What is a sham link? I appear not to have one. Yeah, I can't have. Okay, so I apologize. It's a little bit on me. I strayed from the doc, and that was not a good idea. But they didn't give me the configuration for the other CE or the P router, or not to mention the CE routers and these hosts, whatever that is. So it's not all on me that I messed this up. And not only that, I went back and added this, and I saw big changes in doing that. So yeah, I think I'm going to need a look at what is meant to go on the P, especially when it is as it is concerned with yeah. So unfortunately, I'm gonna have to move on. I'm gonna mark this as done and come back for Anycast RD MS DP. Hopefully that starts to clear things up. But I've just I think done too much. So might have to come back to multicast because I really don't understand it. But for now, I want to stick to my plan of one topic a day, because I don't realize how fast time is moving right now. It's moving faster than I'm capable of realizing. So, oops, actually the next is going to be PIM-SSM. Okay, so maybe that's not so different than the current one. We might have a more clear example associated with that. All right, so that's it for the video. Thanks for watching, and see you in the next one.